Hello everyone, I hope you are doing great. In this tutorial we are going to see how to analyze Likert scale using different types of statistics, namely descriptive statistics as well as inferential statistics. Okay, so in this tutorial we are going to see first how to do a factor analysis in case we have a Likert scale that consists of different items and the sample size is more than 100 respondents. Then we can test the reliability of the sub-factors of the factor analysis so that we can see whether the factors are reliable according to Cronbach's alpha or not. And then we can run other statistical tests, but before this we can compute the variable that is the overall score of Likert scale and the sub-scores of the different factors. All right, and we need to also consider other advanced statistical tests like we have correlation in case of continuous data, and when we have different scales. We can also use independent samples t-test or the Mann-Whitney U-test to compare gender and the Likert scale. I mean, whether or not there is any statistically significant difference between male and female respondents with regard to the Likert scale, for instance, etc. So let's get started with this. So we have a questionnaire that consists of different Likert scales of leadership, organizational productivity, and other types of and employee performance, and we want to calculate let's say we want to analyze leadership style according to factor analysis to see the dimensions of leadership. Okay, so to do this operation, so here we have our scale, strongly disagree to strongly agree. All right, and then we need to go to analyze and dimension reduction, and we go to factor. All right, and so I want to move all the items of the scale, that is the leadership scale, to the variable list. All right, so here it is, so we can start with the okay. So I'm going to click Control and keep selecting an item after another, so that we can select all the items. All right, okay, so 12, we have 13, 14, 15, 16, 17. All right, so we move them here and we go to descriptives. I can choose initial solution, coefficient, this determinant, and chemo and Bartlett's test of sphericity, and click continue. Then for the extraction method, I'm going to use principal components. Can take a discrete plot. For the visual representation, keep everything the same. Click continue. For rotation, I'm going to click Varimax rotated solution and keep it like this. Then click OK or continue. Okay, scores, so we can just skip this. For the options, I can sort by size, okay, and suppress small coefficients below 1. All right, okay, click continue and then click OK, and we are waiting for the as you can see here, the factor analysis. So how can we interpret this? You can see the significance of chemo and Bartlett's test of sphericity. This is really great. It's statistically significant, so the model is 0.908 and the determinant equals 0.000. So it's really, this is good indication that the model is doing, let's say it's doing a good job. And then we go to the, here we have 3 components extracted, and these components explain almost 57 of the variance. All right, and then we have the discrete plot We have eigenvalues, and it's more or less a visual representation. We have the components. Okay, so here I can just keep this table and just choose the components. We have the items with higher scores are grouped within the component, the first component, as you can see. So item 17, so this is a rotated matrix. This is a really good model, so I'm going to copy and paste this. This is the component in a rotated way. So what I can do next is that I'm going to see the items and group them together. So here they are grouped, so I don't have this problem of grouping. I need to check the reliability of the items. So to check the reliability of the items within the first scale, I'm going to analyze again scale reliability analysis, and I'm going to group the items. So here the first scale consists of item 17, item 15, 14, 10, 16, etc. 6, 9, 3, etc. Okay, so I'm going to go to item 17, move it again. I'm going to do this step with other items 15, 14, etc. We have 10, 16. So once I move all items, I'm going to put the scale label, which is factor 1, and click OK. So label, so there should not be any space here. So this is for the border is alpha, split half, Gutzbell parallel, strict parallel. So I'm going to opt for alpha and click OK. And you can see the reliability level of items 10, and we have Chromebacks alpha of 9 or 0.921. Alright, so this is the alpha degree of or coefficient alpha of this first component. Alright, so I think we should do the same steps with other components to analyze all the Likert or the components. Alright, the reliability. We need to calculate the score, that is the mean score of the component. So we are going to go to transform, compute variable, and then I'm going to again follow the same procedure. Right, so first I'm going to go to statistic, go to mean, and then 17, 15, 14. So I'm going to keep putting comma after each item. Okay, so I have just 2 commas, so I'm going to keep adding comma like this. Okay, and the last step by calculating the 2 remaining components, component 1 and 12. Okay, done. So next I'm going to do the correlation of these two factors, especially the first and second factor that has been just created. I expect that we should in fact check whether the data is normally distributed or not. But in social sciences, hardly do we find the data that is, let's say, like normally distributed. So in this case, what we are going to do is that we are going simply to let's say suppose that the data is not normally distributed, and we can use the non-parametric version of the correlation test. Okay, in this case we can use Spearman and instead of person correlation. But as a trick that I do is that I just use, I have the output of the two tests performance, so I can later choose which one to keep. All right, so I'm going to go to analyze, I'm going to go to correlate. Okay, correlate bivariate, and then I'm going to move the first factor with the second factor. Right, I'm going to check here Spearman also, so person has already been checked. Okay, okay, so this is correlation. This is the Spearman raw correlation. So there is a statistically significant positive correlation between the first factor and the second factor. All right, okay, which is really great. Then let's say we can, okay, so I can run the other types of statistics. Let's say correlation of the three scores. Okay, analyze, correlate, bivariate, reset, go to the other, leadership, employee performance, organizational activity, then click Spearman, click OK, and have all the tests run. All right, so then I can copy and paste the analysis. There is a negative correlation for organizational activity with leadership style, etc. We want to test the normality of the data, so I'm going to go to analyze and then go to descriptive statistics and then explore. Okay, and I'm going to move all the three scales to the dependent list. Statistics, we can put M estimators, outliers, plots, we can keep stem and leaf, so we can keep histogram, and we put normality plots with tests. This is very important. Click continue. Okay, list-wise, so this is how we can deal with cleaning data and missing values. I'm going to click OK, and then I'm waiting for the normality test. Okay, so let's go to Kolmogorov-Smirnov test and the Shapiro-Ware test. So here these are statistically significant as expected, therefore the data violates the assumption of normality as can be confirmed here by the histogram. This is what confirms our hypothesis of using normality testing, that is the normality distribution of the data. Okay, so let's do this analysis. Okay, so let's go to the other tests. So what I can do here is that I can run the man with new test instead of the independent samples t-test when it comes to gender and education level. So I can use the Cross-Correlates H test. So we have demographics, we have age, we have gender, we have educational level, we have job position, and here we have years of experience. All right, so I can have 3 or 4 variables that need to be analyzed using the Cross-Correlates H test. Okay, Cross-Correlates H test. So what I can do next is analyze the data using the Cross-Correlates H test. So to do this, I'm going to go to analyze, non-parametric statistics. Okay, related samples. So there is another one. Is about key independent samples. So independent samples. Okay, so this is for the gender, so I can go and analyze gender here with the other variables of leadership, employee performance, organizational activity, factor 1, factor 2, factor 3, with them all, and click random model. And we are waiting for it. Retain the null hypothesis. Retain the null hypothesis. No statistically significant difference between male and female respondents, so I don't need any extra work when it comes to this at all right? Okay, so what we can do next is that we can go and analyze the other things. Okay, so what we need to do is that we need to go again to this and then go to analyze, compare means, and so this is for the independent samples t-test and the one-way ANOVA, but we need to do to use the cross-Correlates h-test. So this way I'm going just to look for non-parametric test, legacy dialogues, and I choose key independent samples. Okay. Okay, so we can go for age first, and let's pick up all the factors. Age, how many categories when it comes to age? So we have 1 and 4, so I need to put this. Define the range, so the minimum 1 and the maximum is 4. Cross-Correlates h-test. To analyze the same with other variables. Okay, so we go to compare means, key independent samples, or rather non-parametric tests, key independent samples. Okay, instead of age we are going to put education level, and for the education level we have again 5, so for the range I'm going to put 1 to 5. Again for job position, we have 1 to 5. Okay, so we have 1 to 5. I'm going to go to analyze again. Okay, so this is 1 to 5, find range, and click OK. Okay, then we need to go further with the analysis. Variables that need to be analyzed this way, so I'm going again to go to analyze. Again, let's say we go to non-parametric test, and we go to legacy dialogues, and we go to key independent samples and choose years of experience, and let's say the range years of experience we have 1 to 4. Okay, and click continue and click OK. That's it. So I don't need to do any extra thing. What I need to do now is just interpret the results. So we have multiple tests here, and we need to interpret the results and write the report in EPA style. So this is in general how we can do all these tests depending on the variables and depending on many things. Um, I'm going to include another tutorial in which I'm going to explain the meanings of each let's say test on how we can interpret it. All right, so stay tuned for this tutorial.